Every time you open Netflix, you assume you're looking at Netflix, but you're actually looking at a one-of-one dynamically generated interface, assembling itself in real time just for you. Objectively best is a human judgment that an algorithm cannot compute. Netflix replaces the search for universal quality with a focus on immediate, local probability. The algorithm builds a personalized decision surface. It predicts exactly what this specific user wants to watch right now, turning the homepage into a predictive tool. The system must work fast. If a user doesn't find something compelling within a few seconds, they close the app and move on. Catching a user before they lose interest requires a sprawling, invisible architecture. It is a system that takes deep, offline machine learning and forces it to operate at the split-second speed of live product design. To predict what you want, the system first maps out what you do, recording every interaction. Binging an entire season of a show is a massive positive signal. Pausing a movie after 2 minutes and never returning is a highly specific negative signal. Netflix abandons simple genre tags, relying on embeddings. Users and movies are converted into vectors, mathematical shapes plotted in a vast, multidimensional space. Predicting preference simply becomes measuring distance. The system calculates how close your point is to a cluster of content. But human taste isn't static, so the data runs through 2 separate pipelines. An offline batch processor calculates your deep historical viewing habits, while a real-time stream processor tracks your immediate session. If you watch 3 stand-up specials in a row tonight, the system adapts right away. The entire intelligence gathering phase zeroes in on a moving target. It cross-references your long-term identity with your present moment intent. All that data waits until the moment you tap the app. That tap fires the real-time pipeline, a process that has mere milliseconds to execute. The system first casts a wide net, grabbing thousands of potential titles. Strict business logic instantly filters out titles blocked by regional licensing or safety constraints. Finally, a ranking model scores the survivors, predicting the probability of sustained, meaningful watch time. In less time than it takes to blink, that massive global catalog is stripped down and transformed into a highly targeted, mathematically scored shortlist generated for one user. A single ranked list makes for a terrible interface. The system has to construct a homepage. It applies diversity constraints to generate distinct horizontal rows, ensuring you don't get a monolithic wall of crime documentaries, even if they are your favorite genre. The interface also has to explain itself. When the system displays a row titled "Because You Watched," it connects similar titles in a way that aligns with human logic. Transparent recommendations build user trust. The presentation itself is personalized. The system dynamically swaps out the thumbnail artwork for the exact same movie, displaying an action-packed poster if you like thrillers, or a romantic one if you prefer rom-coms. It is customizing the doorway into the catalog. Generating this much custom detail for millions of simultaneous users is physically impossible to compute from scratch every single millisecond. The architecture relies heavily on predictive caching layers, storing pre-computed sections of your homepage so they load instantly. Physical hardware fails. Network requests time out. When the complex ranking model breaks, the system drops into fallback modes, instantly substituting a pre-calculated list of globally popular shows. A blank error screen is the worst possible outcome. The architecture is built to prioritize a resilient, gracefully degrading product over a perfect but fragile machine learning model. Algorithmic recommendations shape user behavior as much as they reflect it. When the system highlights a specific title, the resulting spike in views convinces the model the show is high quality, creating a self-reinforcing popularity bias. To prevent users from getting stuck in an endless loop of identical content, the system forces a balance. It exploits what it knows you like, but deliberately injects novel, unproven content, exploring the edges of your taste to prevent fatigue. Every tweak to this algorithm has to be proven in the wild. Engineers deploy massive A/B tests to monitor real human interaction, ensuring that a new model drives consistent long-term retention rather than a short-term spike in empty clicks. Event streams record behavior, machine learning maps out taste, candidate funnels narrow the options, and a UI engine builds the personalized display.